these topics. We will start from introduction, then we will go to basic probability theory and we will discuss some concepts. After that, we will discuss probability space, what is omega, what is F and what is P. And lastly, we will discuss types of events, what are independent and dependent events. Dear students, the word of probability is associated with the random processes and random experiments. In other words, we can say it is a sequence of different processes, statements, experiments, trials, which result in one of the number of different possible outcomes. Dear students, we will start from basic probability concepts. We call the triplet omega, F, P as the probability space. So in this triplet, every number has its own importance and explanations. So we start from the definition of this triplet because every member in this triplet is very important and needs consideration. We start from the definition of omega. It is read as omega and it is called the sample space. The sample space for an experiment is the set of outcomes S such that any experiment or trial results in one and only one element of the set S, where each element in the set S is referred as the outcome of the experiment. Dear students, consider the following example. Suppose we flip the coin twice and note down the outcome whether it is a head or tail. Then the sample space will be given by omega and it consists of head and head, head and tail, tail and head and both tails. So in this sample space we have 4 events. Consider another example. Suppose you make a phone call to your friend and note down the duration of call. Maximum time allowed is 5 minutes. Then what can be the duration of the call? Dear students, here the sample space will be any time t belonging to 0 to 5. That is, your time can be 0 minutes or your time can be 5 minutes or it can be any number between 0 and 5. So duration can be any time from 0 minute to 5 minutes. So in this case, we say that the sample space is infinite. Now we come to our second member. It is called F. So it is called the sigma field and it is read as sigma field. It has the following properties. Number 1, phi and omega both belongs to F. Number 2, if A is any event which belongs to F, then its complement A complement also belongs to F. Number 3, if AI are events that belongs to F, then their infinite union, that is union I from 1 to infinity, AI belongs to F. That is, their infinite union also belongs to the sigma field. So we can say that we arrange the sample space in a special order to get the sigma field F. Dear students, now we consider an example. Let an event A belongs to omega. Then we have the following sigma field F. That is, F is given by phi, omega, A and A complement. So this sigma field consists of 4 members. Now we define P. It is called the probability measure and it is a function f from omega to 0, 1. That is, it is a real valued function with range of 0 to 1, taking any value in the interval 0 to 1. So if the probability of some event is 0, it means that it is impossible event. That is, the event cannot happen. And if the probability of some event E in the sample space is 1, it means that the occurrence of this event is quite sure. It means that this event will definitely happen. And all the other probabilities lie between these values 0 and 1. So we can say that P is a function between 0 and 1 with the following condition. That is, 0 is less than or equal to probability of E is less than or equal to 1 for all the events E belonging to the sample space omega. Dear students, now we define what is an event. A subset of a sample space omega is called an event. We denote it by E and explain it with the help of Venn diagram. So consider the following Venn diagram. We have the sample space omega represented by this rectangle. Then inside this rectangle we have event E, which is represented by circle. Now we discuss different types of events. So we start from mutually exclusive events. A set of events is said to be mutually exclusive if the occurrence of any one event precludes the occurrence of another event. That is, the events E1, E2 up till so on En are called mutually exclusive if Ei intersection Ej is empty. That is, if I is not equal to j. Ei intersection Ej is empty if I is not equal to j for all I and j's from 1 to n. Example. Consider the example of flipping a coin. The possible outcomes are head and tail. Since the occurrence of head precludes the occurrence of tail, and similarly the occurrence of tail precludes the occurrence of head, so these two events are called mutually exclusive. So these two events are represented by the Venn diagram. See below, we have the sample space omega. Then the events E1 and E2 are represented by the two circles inside this rectangle, and we can see that there is nothing common between E1 and E2. So we can say E1 intersection E2 is equal to phi, that is empty set. So this is the Venn diagram for mutually exclusive events. Dear students, if we consider the example of rolling the dice and noting the top measurement, that is, let us suppose that E1 is the event that top shows 1 and E2 is the event that the top member is less than or equal to 3, then the events E1 and E2 are not mutually exclusive because the occurrence of one does not necessarily preclude the occurrence of other. That is, if the top shows 1, then it means that both events E1 and E2 have occurred. So you can see this with the help of this Venn diagram. We have sample space omega, and inside we have two circles E1 and E2 representing two events, and you can see that we have something common between E1 and E2 as we have shown below. So we can say that E1 intersection E2 is not empty. Dear students, a set of events E1, E2 and En are called collectively exhaustive events if their union makes the whole sample space omega. That is, we write union I from 1 to n Ei is equal to omega. Dear students, now consider an example. Consider the previous example of flipping the coin. Then these two events are collectively exhaustive, since the union of head and tail accounts all the possible outcomes. Consider now the flipping of coin twice. Then the events head tail, head head and tail tail are not collectively exhaustive, since their union doesn't make the whole sample space. We know that there is a possible event T and H, tail and head. So therefore these three events mentioned above are not collectively exhaustive. Dear students, now we consider an example. Consider the following table in which the first column shows the sex, male or females. Second column shows the characteristics of 1000 applicants, whether they have college degree, they have high school degree or they have no degree. And in the last column we have the total number of students. So this table shows 1000 applicants for some administrative positions, and these applicants are classified by the sex and by the highest educational degree they have received. Dear students, for this example, suppose that one applicant is to be selected at random in an experiment, then the sample space consists of the following outcomes. That is, the outcomes for this sample space will be male with college degree, MC, male with high school degree, MH, and male with no degree represented by MN. And similarly, female with college degree, female with high school degree, and female with no degree. So this will be the sample space. So now we want to check that whether the following statements are mutually exclusive and or collectively exhaustive. So dear students, we have the following questions. Number 1, if we have the set of male and female, and number 2, we have male, female and high school degree, and similarly we have the next 4 sets. Dear students, considering the first example where we have M and F, first we check these events for mutually exclusive property. The two events M and F are mutually exclusive since the occurrence of a male applicant precludes the occurrence of a female, and similarly for the opposite case. So these two events are mutually exclusive. Also, these two events are collectively exhaustive because the two events include all the possible outcomes of the sample space, because the whole sample space consists of males and females. Dear students, now coming to the second example where we have M, F and H. The three events M, F and H are not mutually exclusive because the occurrence of a male applicant M does not preclude the occurrence of a high school degree applicant H. Similarly, reasoning can be given for F and H. So these three events are collectively exhaustive since all the possible outcomes are included if we take the union of these three events. Consider the example 3 where we have C, H, N, M and F. These 5 events are not mutually exclusive since if we take C and F, then there can be a college applicant which is a female, but these 5 events are collectively exhaustive because C, H and N includes all the applicants. Example number 4. Dear students, here we have MC, MH, MN and F. These 4 events are mutually exclusive because the occurrence of any one precludes the occurrence of other. Also, these 4 events are collectively exhaustive because the union of MC, MH and MN contains all the males, whether F contains all the females. So when we join these males and females, we have the collectively exhaustive events. Similarly, for the example number 5, we see that these 5 events are not mutually exclusive because MC and C contain some common members. Similarly, FC and C may contain some common entries, but these 5 events are collectively exhaustive since the union of C, H and N contains all the applicants. Dear students, for example number 6, we see that these 3 events are mutually exclusive since FC and FH contains females with college degree and high school degree, so nothing common. Similarly, the third one is male applicants, so nothing common, but it is not collectively exhaustive because females with no degree FN is not present in this set. So these events are not collectively exhaustive. Dear students, now we define relative frequency. Suppose that an experiment is performed and possible outcomes of the random experiment are n. Now if m of these outcomes are our favorable, then the probability of the favorable event can be thought of a relative frequency, and it is given by m ratio n or m divided by n. For example, we flip a coin and note down the result whether it is a head or tail. If we are interested in head, then its relative frequency will be 1 by 2. It means that there are 50% chances when we flip the coin we get the head. So similarly, there will be 50% chances for the tail. Dear students, now consider the following example. We consider the previous example once again where we had the following data. We have sex, male, females, then we have highest degree, whether it's college, high school or having no degree. Then in the last column we have the total number of applicants. So assume that an applicant is selected at random from the pool of 1000 applicants, and also that each applicant has an equal chances of being selected. Now using the definition of relative frequency, we can estimate the probability that a selected applicant has certain characteristics. So we can solve this example for an applicant which will have definitely some certain characteristics. For example, the probability that a selected applicant is a male. So first of all, we try to find that what will be the probability that the selected applicant is male. It is denoted by P of M, probability of male, and it is given by total number of males divided by total number of applicants. That is, probability of M is equal to 490 divided by 1000. So that is 0.49. Now 0.49 means that 49% chances that the selected applicant is a male. Dear students, similarly the probability that selected applicant will have a high school diploma as the highest degree is given by probability of H, and it will be number of applicants having high school degree divided by the total number of applicants. Since the number of applicants having high school degree is 310, so we get probability of H is equal to 310 divided by 1000, so it will be equal to 0.310. Next, the probability that selected applicant will be a male with no degree is given by probability of Mn. That is, probability of a male with no degree, and it will be given by number of male applicants having no degree divided by the total number of applicants. So probability of Mn is equal to number of males having no degree divided by total number of applicants. So this will be equal to 40 divided by 1000, and it is equal to 0.040. Similarly, the probability that a selected applicant will be a female with college degree is given by probability of Fc. So it will be given by number of female applicants with college degree divided by the total number of applicants. So we get probability of Fc is equal to 275 divided by 1000. So it is equal to 0.275. So moving in the same way, we summarize the table which gives the information about the probabilities of a selected applicant with different characteristics. Dear students, so we can calculate all these probabilities with the formulas we have done for the 5 examples. So dear students, going in the same way, we get the following table for the probabilities of selected applicants with different characteristics. And you can see that in the last column, when we add all the probabilities, we get 1. Dear students, some important points about the previous tables are given by: number 1, the sum of probabilities of male and female applicants is equal to 1. The sum of probabilities of applicants having college degree, high school degree or no degree is also equal to 1. The reason behind is that the events in both the cases are mutually exclusive and collectively exhaustive.